Caitlin Smallwood gave a talk at the inaugural WiDS conference in 2015 about Netflix and how they leverage data science in recommendation systems as well as in content decisions. It was an incredibly interesting talk and definitely a highlight of that conference. Although this talk was given 5 years ago, it is still very valuable and gives some excellent insights into the broad range of techniques that Netflix uses and the process they follow for conducting experiments, interpreting results, and testing whether algorithms they're designing are really valuable. You can also check out Caitlin's fireside chat at WiDS 2017 as she was part of the opening keynote. That video, as well as all of the WiDS Stanford videos, are on the WiDS YouTube channel.
Okay, well, it's great to be here. It's really an extraordinary thing to see a room full of so many women. It's quite inspiring to me, and to hear what everyone's up to in the field of data science, of course. So many of you have probably seen this user interface if you're a Netflix member. This is the home page of, if you log in on the website. And Netflix is sort of known for its personalization back from the time of the Netflix Prize many, many years ago. All of what you see on the homepage is personalized, and some of the strongest evidence for that is the labels that you see on the rows. And in this example, you can see some of those labels here. Everyone's going to see a different set of labels in your user interface that's personalized to you. And I love to think about the variety of human tastes that are represented in people's movie and TV viewing preferences. This is one way to look at that. There are many ways to try to absorb the tastes that people have. But this is just a plot. On the y-axis, you have the percentage of Netflix members who have seen a particular row label. There are more than 50,000 distinct row labels that are shown to our members in, say, a typical month on Netflix. And of course, that's somewhat a function of the labeling aspects and how the data is tagged and whatnot. But to me, it's astonishing, and this graph is not even drawn at scale. If I drew it at scale, you wouldn't even be able to see the head of that, but I wanted you to see that there is a little bit of shape to it. Whoops. And in the head of that are common genres like comedies, et cetera. And in the tail, you've got all sorts of very specific labels that are trying to get at grouping content in ways that satisfy people's tastes. How many people can identify with at least one of those areas in the tail? You would watch some, not that particular title, that's just a representative title, yeah. Okay, so fascinating stuff, right? So obviously, if you're a machine, if you're the algorithms and part of the recommender system at Netflix, this is awesome that you have this specificity in the data and this massive set of tastes, and you can digest that and leverage that. If you're a human and you're trying to get, grasp in your head what are these tastes across the entire population of Netflix members, it's really tough. So I want to talk for a second before coming back to the recommender system, which I will, about one of the areas where we try to leverage data science for the humans at Netflix who are making decisions, and that is in our content space. So we have a tremendously talented group of experts in content that are located down in Beverly Hills, negotiating with people in Hollywood, trying to make decisions about the next Netflix original that we might decide to take on as a project, right? And of course, they're creative people, right? They don't want to have to think about algorithms and data and whatnot, right? But meanwhile, on the data side, we have this massive advantage of all this data about our members' tastes. And so we try to leverage that to help in the decision making there. And here's just a quick list of some of the things we do. So we have a big system of many, many different models that are trying to predict the demand for a title that we might acquire on Netflix. Really hairy space, a lot of nebulous aspects to it, but nevertheless, it's using a lot of the same techniques as the recommender system. Very close cousin, in a way, to the recommender system, where on the recommender system, you're collapsing everything eventually down to the user, the personalizing for the user. Here, it's just turning that on its head and collapsing it down to a particular title. But fascinating space for problems there. We also do a lot with clustering, but not in the same vein of what I showed you before, not with that many different groupings of titles. Here, we're trying to identify a smaller set of clusters that humans can hold in their brain to understand the array of tastes. And even techniques like factor analysis that's been around for decades and decades prove really useful here because they're really trying to separate out the distinct aspects of people's tastes. And so we have evolved a set of clusters that's actually quite robust and stable over time and in different scenarios that really help for planning what the catalog should look like in order to satisfy everyone's tastes. And then a third area is really this title-title similarity. Many classic problems in this space that folks have leveraged this for in title-title similarity or item-to-item similarity. But it's especially useful to us when we're thinking about new original titles, right? So this is a hard problem. There's no data. Somebody gives you a script, and maybe there's a little bit of a talent, maybe an actor or something attached to the project, but you really don't have a lot of data to go on. But the content experts and the folks in the creative field, right, they have a sense of what this title might be. So imagine we had gotten the script for House of Cards, and somebody goes, you know what, it's actually kind of like, what do I have here, West Wing meets Breaking Bad, right? Which, not a bad guess, but they know this content in their head and the way they're seeing the project evolving. So still not a lot of data, but what do we do with that? Well, we can actually study that audience, right? We can say who's watched those titles, what else have they watched? And you might still be going, well, how's that helping us? Well, it really helps us to then estimate the demand for the title. And there's a whole fun sub-problem space here in trying to figure out, even what's the right depth to go to in terms of the number of similar titles that then help us best identify an applicable audience, right? Anyway, fascinating area. I wanted to touch on it because it's more, how do you merge data science with the human decision making? One of the harder areas, I think, in data science. But back to the recommender system. So it's been quite a while since the Netflix prize, and the Netflix recommender system has evolved into a much broader thing. And you can see there a list of the many types of algorithms that are part of the recommender system today. The Netflix prize is down there somewhere, the star ratings predictions, right? That's still part of the recommender system. But we have many, many other problems that we've solved and kind of separated out into spaces that we address with algorithms. Everything from constructing the page, picking the rows for the page, sequencing the rows on the page, ranking the titles within each row, title-to-title similarity, you'll see rows like because you've watched House of Cards, other titles, right? And then many of the rows, this is probably not as well known, many of the specific rows have their own specialized algorithm behind them. An example of that is the continue watching row that's actually trying to predict the probability that you'll pick up watching a title that you had started before, and it has a completely separate algorithm behind that. So there are many techniques we use. I think it's really exciting actually to be part of a system that is using so many different techniques. It's quite a broad kind of a system. Almost all the techniques listed here are part of the recommender system today, save deep learning is an area we haven't really embedded into the system today, but a lot of this other stuff is part of the system, and we're constantly trying to evolve and explore what else we might do. Features that go into those models are another fascinating part of data science, and frankly, it's one of my favorites, is thinking through all the possible signals that could actually make a difference in a model. And I don't know what everyone else's experience has been, but in my several decades of being involved in predictive modeling and other aspects of data science, I've often found that the signals that you can identify can have an even bigger impact on the model than the technique itself. Because there are so many great techniques, and as long as you're kind of following appropriate constructs for the problem at hand, many techniques can be useful. But the signals can really dramatically change the results of a model. So we have a lot of fun with that. All right, so we're really into evolving the recommender system over time. It's been a massive commitment from the company ongoing from day one, really, at the company to try to invest in this area. So we're always investigating new techniques and new models, et cetera. So how do we do that? We have a lot of people who are super psyched about working on deep machine learning algorithms who study new prospective algorithms. And then if they get a great result offline when they train their model, validate the model, et cetera, and it looks like the model fit or its predictive power is stronger than whatever the that particular main algorithm is in the product, then we'll run an experiment. And I want to now talk about experimentation a bit. And I assume most people are sort of familiar with what an experiment is. You sample your audience, you give people different experiences, then you observe the behavior over time and measure and compare how people responded, right? So I just want to touch on the intuition behind an experiment. I think it's so important to really grasp the power of an experiment. This is just an example of Kindle sales on Amazon. And the blue bars represent one version of their website, and the red bars represent a different version of their website. And you might look at this and go, okay, that new website was better. But it turns out that on that same day, Oprah mentioned that Kindle is her favorite new thing. And so now we have a problem, right? Now we don't know whether that increase is due to the new website or whether it's due to Oprah. And that really is the core of experimentation. It's trying to figure out, is the change that you made the cause of the behavioral change that you might then measure? And so, you know, the beauty here is that an experiment really lets you get at causation. Versus everything else is really correlation. Even our best predictive models, right, really at their core, it's correlation. Sure, we're trying to eke towards causation. We're trying, you know, there's all sorts of research in causal inference. I'm a big fan of all this stuff. I'm not at all putting it down. I'm just saying that when you can have an opportunity to run an experiment, you can learn a tremendous amount beyond what you can with the techniques in isolation. So in that same example, had they been running, which I'm sure they did, you know, ran their website, both versions at the same time, you can now see what's really going on, that actually website A appears to be driving more Kindle sales if that difference is statistically significant. Okay, so for us at Netflix, you know, other reasons we experiment with our algorithms, one is that when you're training a model, you need a dependent variable that's sensitive, right? And for us, what the models are really trained on is the probability that you'll play that next title that we're going to recommend to you. But that's not really the same thing as enjoying it, right? Just if we can entice you to play it, that doesn't mean you liked it, and nor does it mean that you enjoy a Netflix service and that you're willing to continue with Netflix month over month. So that's one reason that an experiment helps us validate whether the model's actually an improvement. And you know, another thing for us is just, of course, that the training data is all biased toward whatever the recommendation algorithms were doing in the past. Not to mention popularity bias, or, you know, whatever we show you, you're probably more likely to play that than the things that you have to really scroll and search for. So just to pause on what does it mean to test at scale, it's an amazing thing, right? And there are many companies today who really run their business this way. There are many who don't. But what it really means is if you're in an experimentation environment, you have no one product at any one time. You might kind of think, oh, there's one main Netflix product, and then there's a little bit of testing on the side. That's totally not how it is. I'm sure that's not how it is for Amazon, Google, et cetera, right? You actually have many, many, many thousands actually of versions of your product that are out there at once. There, at any one point in time, there are different in different segments of your product, there's the portion, for that component, there's the main, you know, incumbent winner. But at any one time, you know, there are just all these products out there. So it's a really, it's a different framework to think of your product in. And in the algorithm space, we test around 500 different variants of algorithms each year. So we do try to, you know, the way to make it all work when you've got so many tests going at once is really to try to come up with an architecture for your whole product that has these separate components that are independent from each other in terms of the customer experience, so that you don't have test conflicts going on. So that's a key part to kind of setting up a whole framework. So I'm just going to go through an example of an experiment and say a bit more along the way. So here's a row called Trending Now that used to not be part of Netflix. I think we launched it maybe about 6 months ago, something like that. And of course, before we launched it, we tested it. And what does that mean? We didn't just throw in a row and test the presence or absence of the row and compare those two things. We tested many other aspects of this, right? There's the algorithm itself. There are the signals, the parameters in the algorithm. There's also the degree of personalization. Should we have a Trending Now row that's the same for everybody? Or should we still personalize the titles that are within that row? And if so, how much? How much should we bias that row toward popularity versus personal preference? So many, many things. And in the end, we had 16 different variations of this algorithm that we tested as for this one kind of quote test. And then, once you kind of set that up, now the test goes into engineering mode. And this is where all the folks who really love working on the specific algorithms are developing the algorithms, tuning them, validating the models, et cetera, and developing these 16 different versions, right? Now, often along the way, versions will die or new versions will be born because, in that process of innovating on the trending now concept, people will come up with other ideas, and by the time the test is actually ready to launch, you may have slightly different, setup than you thought initially. A lot of engineering work. A key thing to highlight is how much thought needs to go into holding everything else constant, right? So if you back up to the high-level intent of running a controlled experiment is that you're controlling everything else. It's really hard to control everything else. I will tell you how we over and over fall down on this. No matter how good we get at this, it's so hard and it's so specific to each test. And I've listed a couple examples there for the trending now test, right? If you just insert a row, you're going to have one more row on the page, and lo and behold, people are going to have more total things to choose from as they scroll down, and they're going to stream more, and they might retain at higher rates. And so all of a sudden we've thrown our test just because now we don't have a valid control, right? There are many, many things to think about with each test to make sure you're trying to control for everything. Netnet, it's a huge investment. I mentioned before, there's a lot of commitment to being a testing kind of company. It is a massive investment for us across the board. So once the test is ready, we're ready to sample members and kick off the test. That is another wonderful area of research and deep data sciences on how to sample. Massive random sample is awesome. You can't always get massive, and so there are many other techniques to leverage to try to make sure you're getting a great sample. And then there's also who are you going to test on, or what entities are you testing on, right? Netflix, we really prefer to test with new members when they sign up for Netflix because they're not tainted by previous experience. And in addition to that, they're more sensitive. Maybe they're just trying Netflix, doing their free trial. And once people have retained in Netflix for more than a month, they'll generally stay much longer. So it's a less sensitive signal to study people who've been around for a long time. So sample. And then the next thing we do is wait. And this is one of the hardest parts. We're all curious to look at the data early on, and it can be very misleading early on. But we run our experiments typically for about 3 months. Much longer than companies, search engines and whatnot have the luxury of. The business model is attached to each search. For us, our business model is attached to the monthly retention, right, that customers have. So we wait. And the other reason we wait in algorithms in particular is because the personalization unfolds as you play things. When you're a new member and you haven't played anything, we don't have a lot of data about you. As the minute you play one title, the quality of the recommendations will really jump up. And once you've played 3 or 4 titles, really jumps up even more, right? And so we need to watch over time as you play more things to see whether the algorithms are really working for you. And then here's an example of the output from this particular experiment. I'm not really sharing any numbers, but you can see there's some of the metrics we looked at in the rows, and then the columns are all the different variations of that trending now algorithm that I mentioned. You can see that test cells 5 and 12, those variants of the algorithm worked quite well. And another whole aspect of experimentation is getting really good at the interpretation of the results, right? It's still just statistics. There's statistical error. There's all sorts of opportunity for bugs or problems in the experiment itself. And so it's super important to not just take a blind look at the data and just say, okay, the data must be right. Got to look for consistency across the metrics. You need to see that there's a story that makes sense. That book, The Signal and the Noise, is great at kind of pointing out some of this stuff. So we look for a consistent story also across test cells that are related. So since all these algorithms are related, you would expect to see multiple cells, multiple variations of the algorithm doing something. If you only saw one variant of the algorithm doing something and you knew from a logical standpoint that that version of the algorithm was quite similar to the others, that's a little fishy, right? So you kind of have to put all these pieces together in interpreting the results. So what I really want to kind of convey about this experimentation is how valuable it really truly is. We have many, many algorithms that look promising when somebody develops the model offline. And then only a minority of these win when tested. And I'll tell you that when we looked at across all of our tests over a period of a year, about half of them showed some sort of win. 10% of them showed a material win where we actually moved retention. And many, many, many of them were flat or negative. So the point is, these are all things that we already thought were great. The offline model looked great. So, so the lesson here is, hey, you really do get a lot more information out of experimentation than you do just with the models alone. And the other thing, of course, that's great if you're in a business with consumers and that kind of thing is that you get to let them have a vote. They're the ones really making the decision rather than hot-headed people inside the company, feeling like their algorithm is king. So it's really nice to have them be the arbiter. I just want to wrap up with more of a philosophical point about data science. I feel like it's a tremendous time in our world to have access to so much data. I hope it stays that way. You never know how things will evolve over time. And I think it's also a tremendous responsibility, right? People don't realize, most people don't realize how much of their data is there and how accessible it is and how it's used and things like that. And I very strongly believe that we all have a big responsibility there to use the data well and to be great custodians of people's data. In particular with experimentation, there are interesting things to think about because you're intentionally giving different versions of your service or whatnot to different sets of people. Those people are all paying the same amount of money to use the service, and so you have to be quite careful in terms of what types of experiments are okay to run and what types of experiments are not okay to run. I feel very grateful that at Netflix we do think quite seriously about that. We have a couple of different principles. We have an opportunity for members to opt out of testing completely if they want to in the account settings. We also think carefully about which tests are fair. We wouldn't, try something on one type of one set of the population in order to benefit a different type of customer. We also will always, in all the varieties of the experiments, provide the basics of the service, all the content on all devices at any point in time, like unlimited streaming, right? So kind of the basic contract that you have with someone I really feel needs to be honored. And then just the intent to experiment on things where you have a hypothesis that it's a positive thing, rather than doing something that ahead of time you think might be a slightly degraded experience, but you think you might learn something valuable. We will just say, oh shoot, we wish we could test that, but we're not going to, right? And there are legalities that help with a lot of aspects of data stewardship, right? But they don't get at these more subtle things around how to really be responsible with people's data. So with that, have a good lunch. Thank you.